They are finding some debris down in here. There were some old buildings here at some point.
This is a swimming pond. This is one of those recreational style ponds where we're using biological filtration, proper circulation, bacteria, enzymes, all these different strategies that we use on our standard ecosystem ponds, kind of blown up a little bit more stuff in them, but the philosophy is the same. Hey, what's up everybody? Ed the Pond Professor here, coming to you from my office today, working on a design for a really cool project. A couple years ago, we were involved in a really amazing project up in Wisconsin Dells with the Mikowski brothers. They had an incredible idea of indoors, outdoors, you name it. And these guys have been involved in that industry since they were born. Wisconsin Dells was founded because of the beautiful Wisconsin River that goes through that area. What they wanted to do was go back to that. This is a swimming pond. This is one of those recreational style ponds where we're using biological filtration, proper circulation, bacteria, enzymes, all these different strategies that we use on our standard ecosystem ponds, kind of blown up a little bit more stuff in them, but the philosophy is the same. They wanted to create an ecosystem like that was designed for swimming and for all types of outdoor activities, and they knocked it out of the park. It was a huge hit. In fact, so much so that they want to build a second one. So this project, the original one, what they want to do with it is that's going to kind of be more of a quiet type of a beach. Parents kind of hanging out, relaxing, maybe some of the kids swimming around and things like that, but a little bit more low key. The new one, it's basically going to be like a huge sand dune type of an environment. Big giant beaches, sand bottom, big slip and slide coming down over on the edges and everything. So a little bit more active, involved with a lot of different play type activities. So it's going to be a little bit different environment. Plus they needed more space. They've been adding, they've been growing, so they wanted to create this new one. So there are a few challenges associated with it, and that's exactly why I kind of want to go over the design here, and that's because there are some unique pieces that we have to take into consideration as we move forward throughout this project. Now there's a couple things that we cannot move. So one of them is this right here. So this is an existing beautiful oak tree, kind of that signature piece. It's been there for a long time. It was surrounded by all this parking lot. They want to protect that because having that beautiful oak tree there is going to create some shade in and around that water feature. The other things that we cannot move is there are parking lots still in existence all through all of this stuff. What we're trying to do is tuck this little pond right in this little pocket over here. So the idea, dig this all out, take all that soil, build up this huge mound to create not a waterfall, but a big giant slide, like a big slip and slide type of a setup. Kids can kind of jump in this big flume basically, and they shoot down this thing into this deep pocket of the water. There are going to be these incredible floating structures out there for kids to climb all over, jump off into the water. So it's going to be highly interactive, but I want to make sure that they have everything that they're looking for. So a couple things that I'm looking at is the overall square footage. So you can see here, we mark that out. We're approximately 10,000 square feet. What we want to do is we want to create a wetland filter that's going to be able to detoxify all of that water. Okay, so if you're looking at this picture right over in here, I want to tuck an intake bay. These little stalls that they have are actually kind of marking out for possible tiny homes. They have several tiny homes on the property. They also have camping areas. They have these cool tree houses. They got cabins. They got all types of interesting things. But this tiny home movement is very popular right now. So they're talking about adding more of them. But because of the space restraints here, I think we're gonna have to eliminate several of them. So I want to tuck an intake bay into this corner. This area over here on this other side of the tree is gonna be our wetland filter. And that's just because this is the space that we have to deal with. Because of all the sand in this, we're gonna have a series of our brand new Ext pumps. These are incredible pumps. We've been testing them for a couple years now. These are designed for this recreational style pond because the motor is actually outside of the body of water. So this is gonna meet all the codes and regulations. I wanted to create something that was gonna help with overall water quality. So I oversized the intake bay. We're gonna be moving approximately 1,000 gallons of water per minute for this pumping system. The minimum size of an intake bay is 1 minute's worth of water. 1,000 GPM, 60,000 gallons per hour, which is a heck of a lot of water flow. We needed a minimum size intake bay of 1,000 gallons. I actually went 10 times that size. So we're actually going with a 10,000 gallon system. And that's because I want to turn this into part of the filtration system. 10,000 gallon reservoir is going to be a huge reservoir. The water is going to stay in the dark, and this is the important part. I'm trying to create a dark, cool area because this is more conducive to biological activity. It's going to have higher dissolved oxygen, which is what we're looking for to deliver that desired water quality. The other thing that I had to take into consideration here is kind of funky. We have two different types of liner. Huge polypropylene liner, and that's because this pond is over 10,000 square feet. And the actual size of the liner is going to be almost 20,000 square feet in size. And that's because we have to go down 7 feet almost, basically, to our maximum depth. You cannot use the standard seaming tapes that we normally use. Two different materials. So what we're going to do is we're going to create a junction in this corner over here where we could seam those together. The other thing that we're going to do is we're going to have a EPDM liner over here for our wetland filter, but that one does not need to be seamed to it. That's because the wetland is slightly higher. So let's move on to our next picture. This is that pipe system. This is going to be a pipe that's going into our intake bay. I'm bringing in a 48-inch diameter polyethylene pipe. I'm going to use this 48-inch pipe to create a very specific suction point. As these pumps, you can see over here, I have this little drawing. I got pumps over here. All the water is going to get drawn through all of these aqua blocks over to our pump area. So that means we're going to have all this flow going through this 48-inch diameter pipe. This is going to help with the overall maintenance because of that big tree, because there's going to be kids playing in it. This is going to create a big suction area to pull all this debris in. It's going to be a great system going over this. We're going to allow all that water to flow through, but it's going to keep large debris out, and it's going to keep children and pets and things like that from going into this pipe system. It's going to slow the water down. So this is going to facilitate that sedimentation process. We have 60,000 gallons per hour of flow. That equates to 1,000 gallons a minute, or down to 16.6 gallons per second. Now, if we take this 48-inch diameter pipe, it's not going to be 100% full. It's going to be about 90% because we need a little bit of an air gap in the top to allow debris to flow through. When we take this pipe, probably be between 16 and 18 feet of actual pipe system. So that's going to be equivalent to approximately 1,500 gallons of water inside of this pipe. So when we have only 16 gallons per second going through, that means it's going to take 90 seconds for that water to flow through. So that's going to slow it down dramatically, and this is going to allow all those sediments time to get out. The reason I'm going through this entire process is sand can be dangerous for pumping systems. So by having this sedimentation trap and having all this water flow through all this stuff, it's going to protect our pumping system. If we move down to the next picture here, you can kind of see I have a little bit of a cross section now of exactly what's happening here. We have our normal water line there. Remember, I want an air gap. This will allow that water to flow through. The other thing that this pipe is doing for us is it's allowing us an opportunity for a connection point for two different types of liners. For the polypropylene liner to attach to the EPDM, we're going to get a precast concrete vault. We're going to drop that in place inside of our liner, and then we're going to have our piping going inside of it. I want you to picture this. Dig a channel, dig out the entire pond. So we got the pond dug on one side, we have our intake on the other. We're going to dig a channel connecting these two together. The two liners are going to lay over inside of there. We have to connect them together. Drop this box culvert in. We're going to take the liners, instead of having them flat like this, we're going to stand them up vertically, just like we would for a skimmer faceplate. But we're going to have this huge, big, giant concrete structure, and then our pipe is going to go inside of that. We'll fill around it with crushed river rock, and that'll lock everything in place. So these are our two different liners. You can see this black over here. This is our EPDM, and then we have our polypropylene on the other side. We're going to bring those two pieces up. We're going to use a series of termination strips or termination bars. We're going to use it as a compression plate. So we're going to have our liner in place. We have our concrete structure on one side. We have our liner. We're going to put our sealant in between. We're going to drill with a concrete drill. We're going to put in a series of Tapcon screws. These are concrete screws using a lot of different applications. We're going to attach that strip directly to the concrete, and when we do that, it's going to create a compression joint. That's going to draw everything in place, and it's going to create a watertight seal. I have done this on a wide variety of projects over the years very, very successfully. So I know this is going to work out really, really well for us. Then the water is going to enter into the aqua block area. We're going to have two stacks of aqua blocks. We're going to have that large river rock on top to act as the pre-filter. So as you can see here, we have a lot of things that we have to think about on this project. I also want to make sure that we have lots of circulation. So I'm going to deliver this water to our wetland filter. We're also going to deliver water to that water slide type of a setup coming down, and we're going to have a series of jets because I want to make sure all this water is being turned over to deliver the desired water quality for this incredible brand new project. Stay tuned on this one. This is going to be an incredible project. Totally looking forward to it because I love a good challenge. This one delivered.
I was out here a couple of weeks ago with Chris Wilson. We did some of the initial layout. Today is construction day. Scraping away some of the crushed stone that is underneath the existing parking lot. We're taking some of this compactable material, putting it down in the bottom because we have a lot of sand. They are finding some debris down in here. There were some old buildings here at some point. We're taking some of the soil that we're pulling out right now, piling it up over in this back corner, and that's because there's going to be a big water slide located in this back section. This is going to be a massive sand dune is the entire idea behind all this stuff. Getting ready, we have multiple things happening. We're doing the excavation for the pond itself. We're also going to start setting everything up for the intake bay, which is going to house our pumps. Doing a little R&D here. We have these mats. These are used in the golf course industry and sand bunkers. We want to have a water distribution system underneath the sand beach. So I want water to flow up through the bottom to keep an aerobic zone, basically, so we don't get anaerobic conditions. So I want to test this by pouring water with a mixture of sand over it to make sure that the water goes through, but the sand does not migrate. So that's what we need to test. We want high flow of water, but we don't want sand to migrate or get clogged inside of this mat. The mountains and mountains of soil. Some of this soil is going to come off site. We're actually pulling this stuff out over here. This is getting staged for some trucks coming in, and that's because it has a lot of debris in it. We have our pipe in way over on that other side. It's a 4-foot diameter pipe that's going to act as a sedimentation chamber between the pond and the pump area. Right here in this middle section, this is going to be the deep area. This is where there's going to be a huge floating structure where kids could bounce and jump and climb all over it. Down here in the bottom, we're actually using sandbags instead of boulders because kids are going to be climbing and jumping all over the place. We want to make sure it's a little bit softer for them. Once we transition up to the next ledge up, that will be all decorative boulders going all the way around the perimeter. So this pond is over 1/4 of an acre in size. It's going to have an average depth of about 5 feet. Excavation is going to come all the way out right about here. Play area over on that side. The area where I'm standing up here, this mounded area is going to have 2 slides coming down into a shallow section of the water. Big jumpy floating thing here in the middle. Large sand beach over on the far other end where there's going to be cabanas and chairs and things like that for the parents to hang out and relax. Pumps are going to be located back over in this section. And then our wetland filtration system, which is responsible for cleaning all this water, is going to be located beyond on the other side of that tree. So you can see we got these little treehouse structures. We're going to have these bridge crossings and everything, and you're going to be walking over that large wetland filter, which is going to kind of create a really cool, unique vantage point.